Okay, so we're going to go through navigation, and this is applications. Still right triangle trig. Okay. Before we go through navigation, we need to go through two definitions. Okay. We need to go through what they mean by the course. Okay, and it might be the course of a ship, plane, person, whatever vehicle. Okay, the course by definition is the angle measured clockwise from the north to the line of travel. It's measured clockwise from the north to the line of travel. Okay, and that's the course. Okay, another key word in navigation is the bearing. Okay, when they ask for the bearing is, both of these are angles. Okay, the bearing is the angle measured clockwise very good. Bearing is the angle measured clockwise from the north. They're both measured clockwise from the north, but the bearing is to the line of sight. Okay, so when you do navigation, everything that we've done before, okay, when we did navigation before, everything started off with 0 here and 90 up here. Now, in navigation, 0 is at the north, okay? 0 is straight north. Clockwise, okay, so if we go clockwise, this would be 90 degrees. This would be 180 degrees if it's going straight south. Okay, this would be 270 degrees. So the difference is 0 is straight up. Okay? Okay. So basically you're figuring everything clockwise from the north. Navigation is a little bit different. Okay, so I'm going to go through two problems, and these are tied together. From a ship traveling on the East Coast on a course of 27 degrees, the navigator sights a lighthouse. Okay, now let's talk about that a minute, because we're not used to having a lighthouse. Okay, what is the purpose of the lighthouse?
Show where land is.
Yeah, to show where land is. So the lighthouse, is the lighthouse on land or on water? It's on land. So when you draw your pictures, do not put your lighthouse out in the water. Okay? The lighthouse is on land. Okay? You laugh, but that's a critical part of the problem. The lighthouse has got to be on land. Okay? The line of sight forms a right angle, and you will figure out that these problems have to be rigged. They are all rigged to give you a right angle. Okay? The line of sight forms a right angle with the ship's line of travel. find the bearing of the lighthouse. Okay, find the bearing. Key word, they're asking for bearing. Okay, so the ship is traveling on the east coast on a course of 27 degrees. Okay, so here's my land. The ship's out here. Okay, now you may have to adjust these as you draw your pictures, but the ship is on a course of 27 degrees. Okay, now when you do these pictures, don't do this micro mini picture. That does you no good because you're going to use the geometry. Okay, so draw a coordinate axis big enough that you can see the angles. It's on a course of 27 degrees. So 0, remember, is up here at the north. 27 degrees, I'm just going to estimate it. This ship's going off this way, but the ship is right here. Okay, anybody having trouble viewing that? Here's your ship. Okay, ship is right here. Okay, going off this way. Okay, that helps. Okay, 27 degrees. Okay, and the line of sight forms a right angle. The navigator is on that ship. The navigator spots a lighthouse. Okay, the lighthouse is over here. You can get creative. There's your lighthouse. Every time I draw this picture, I think of the lighthouse on the Harbor Town 18 lighthouse on the golf course. Famous golf hole. Okay. Huh? Because it's on land. Yep. Because you don't want to put it out in the water. Okay. Okay. So let's go back. From a ship traveling on the east coast on a course of 27 degrees, so we know this angle is 27 degrees. The navigator sights a lighthouse. The line of sight forms a right angle with the ship's line of travel. Okay, so they're telling you this angle is 90 degrees. Okay, that whole thing is 90 degrees. So what's this angle? 90 minus 27 would be, so we know that angle is 63. Okay, now find the bearing of the lighthouse. Now, the critical part of these is to figure out what angle am I looking for. Okay, now we just did this. It's like you're facing straight north. It's like your hand's right here. You're going north. Okay, you want the bearing. So you're going north. There's 0. There's 90. Upside down there's 180. There's 270. And that whole angle is what we're looking for. Okay? So when you're trying to go from the north to the line of sight, what angle is that? How do you get it? Yep, all the way around is 360. Okay, and subtract the 63, be 297. Could we also go? Could we go all the way to here is 270, and could we figure this angle? 270 plus 27, and we still get 297, right? Okay, so that's the answer. Okay, part of it's drawing the picture and understanding the terms that they're asking for. Okay. Okay. Second problem, and this is tied in with the first one. Okay. The ship in example 1 makes a second sighting The ship in example 1 makes a second sighting after traveling 2.2 kilometers from its first position. The course remains 27 degrees. The course remains 27 degrees. The new bearing of the lighthouse is 247 degrees 20 minutes. 247 degrees 20 minutes. Find to the nearest tenth of a kilometer. Find to the nearest tenth of a kilometer the distance of the ship from the lighthouse. Okay, find to the nearest tenth of a kilometer the distance of the ship from the lighthouse when the first sighting occurred. Okay, so we're looking for a distance. Okay, now on this one we still have this is the land over on this side. Okay, and I'm gonna draw this down here. Okay, this is where we started. It was 27 degrees. Okay, and we spotted the lighthouse over here. And you may have to adjust your pictures as you're drawing these. Okay. The ship traveled for 2.2 kilometers. So it traveled for 2.2 kilometers. Up. Okay. It's still on the same course, so it's still heading off. This is still 27 degrees. Okay, but now the navigator sights the lighthouse. Okay, and this angle says the new bearing, and the bearing is from the north all the way around to here. Okay, 247 degrees 20 minutes. Okay, now they've rigged the problem from the beginning because they made this a right angle. Okay, so we do have a right triangle. What they want you to figure, find to the nearest tenth the distance from when the ship first sighted the lighthouse. So you're trying to find that X. Okay, and we know this is 2.2. Okay, now you have to figure an angle. Do we have anything about this angle? No. So it's like you've got to figure out what's this angle inside the triangle. All your geometry comes back. Okay? We know this, it's still on a course of 27 degrees. It was on a course of 27 down here. Okay? We know the whole angle is 247.20. How can we figure this angle inside? Any ideas? Turn this back on. Okay, so we figured out this angle is 27. They are vertical angles are equal. Okay, and then from here to here is 180. So if you add the 180 and the 27, 207, and subtract that, you get 40 degrees 20 minutes. You agree with that? Okay, so that is this angle, 40 degrees 20 minutes. Now we have enough to figure, in terms of that angle, what side is this? Opposite, and this one would be? Opposite over adjacent. Tangent. Alright, so we have tangent of 40 degrees, 20 minutes is opposite over adjacent. So tangent of 40 degrees, 20 minutes. And we've got x divided by 2.2. Okay, so now we need to figure tangent of 40. First, check your calculators, check the mode. Okay. Okay, make sure you're in degree mode. Okay, and tangent of 40 degrees. You got to go to the second function angle. That's been a while since we did that. Pick up the degree symbol. 20, do second function angle. Pick up the minutes. Okay, I get 0.8491. Okay with that? Okay, 0.8491 equals x. Now, don't type in 0.8491 because all those decimals are still in there. You don't round on these until the final answer. So this is x divided by 2.2, so do the inverse. Just take it times 2.2. Okay, and I get 1.8679. Then you got to go back and look at the rounding. Find to the nearest tenth. Okay, so to the nearest tenth, that's 5 or greater, so you round that up. So 1.9 kilometers. Okay. Okay, so every time you move your ship or your plane, you draw a new coordinate axis. You draw them big enough. So that, like I could have done, one of you said alternate interior. You could do alternate interior from here too. Yeah. You could do vertical angles here, or you could do this line parallel to this line and do alternate interiors. Yeah, so you could look at this and say this line is parallel to this line, so this angle is equal to this angle, alternate interior. But if you don't draw those coordinate axes, don't draw micro mini pictures because that won't help. Okay? Okay, that should be enough to get you started.